Alright, so hopefully you got your molar mass assignment all done. This is a little help to get started on assignment number 2, which really starts to apply the idea of the mole. We're not going to do number 1 on your homework because it's just defining what a mole is, and you should know that just like a dozen eggs has 12 and a dozen shirts has 12, a mole is all about Avogadro's number and counting particles in chemistry. Number 2 specifically says how many moles are present in 34 grams of CuOH2. If we needed to, we'd have to go backwards and get the charge of this transition metal. This is called copper 2 hydroxide, but not anything super important here. When you're doing these problems, just like we'd practice in class, we always want to start with the important things. So we want to know that we're starting with 34 grams of copper 2 hydroxide, and we know we want to get to moles. So when we're all said and done, this is what we want on top, and we know that we'll start with what we're given. When you go to start your dimensional analysis, you'll see why some people call this a train track method, because it kind of has that appearance to it. But we always want to start with what we're given. So what we're given here from the problem is that we have 34 grams in this random sample of copper 2 hydroxide, and nothing goes on bottom there because it's basically just a property of 1. We're talking about that itself. As we go through this problem now, we need to figure out, well, how are we going to cancel grams of copper 2 hydroxide, because I know I want to get to moles instead. So in order to cancel grams of copper 2 hydroxide on top, I know I'm going to need to get to grams of copper 2 hydroxide on the bottom. Now we don't necessarily know what value goes here, however we do remember that the top and bottom have to be equivalent, and from our last unit we found out that we always know how much 1 mole of any substance weighs. That property is called molar mass, and we can always figure out how many grams are in 1 mole. So in order to go find this number for copper 2 hydroxide, that molar mass value, I got to go look at my values here, and I got to realize, well, I have 1 copper. That 2 only goes to what's in here, but I do have 2 oxygens and 2 hydrogens from that whole molecule right there. If I add all those up, that comes out to 97.57 for its molar mass, and we have to remember its units are grams per mole, and that hopefully starts to make sense with what we have right here, grams per mole. When we go pop that number in there, the reason why I can do this with this problem and this compound is that they're equivalent with each other. If I counted out 1 mole of particles, Avogadro's number, and weighed it out, it would weigh exactly 97.57 grams, and again, I want grams on bottom so that I can cancel it out over here, and that's what you'll see. Grams divided by grams is going to cancel out, and what that leaves us with then is moles of copper 2 hydroxide left, which is exactly what we wanted in the problem. When we go to type that in on our calculator, it gives us a big old fractional number, which we don't really want. We can see that in the original problem they gave us 2 sig figs, so we're going to round it to 2 sig figs. We're going to label it properly. We canceled out grams, so it's 0.35 moles of copper 2 hydroxide. We boxed our answer to make it look pretty, and we move on. Just make sure you're being a good problem solver and looking at what is the problem asking you to get to, and then you always start with what you're given and talk yourself through, well, how am I going to cancel that out, and what am I going to get on top, and move forward from there. Think outside the box and be problem solvers.